My name is Nurhafiza Binti Abu Bakar. I'm from Class A today. I will present Topic 6, Decision Making Under Uncertainty. In this chapter, we will explore 3 important topics related to decision making under uncertainty. Firstly, we will discuss the paradoxes of decision making, which are complex situations that can lead to unexpected outcomes. Secondly, we will explain binary and multi-valued measures of incompletely known probabilities, which are important tools for making informed decisions when there is incomplete information available. Finally, we will explore the 5 decision criteria for decision making under uncertainty, which are essential for making rational and informed decisions in a variety of contexts. The 2 paradox of uncertainty. The first paradox of uncertainty is the paradox of ideal evidence, which shows that more information does not always lead to better decision making and can sometimes make it more difficult. The second paradox is Ellsberg's paradox, which arises when people's choices violate the expected utility hypothesis and highlights the importance of considering the reliability of probability estimates in decision making. The 2 major types of measures of incompletely known probabilities are: the binary measure divides probability values into 2 groups, possible and impossible values. On the other hand, the multi-valued measure assigns a numerical value to each probability value between 0 and 1, representing the degree of reliability of each particular probability value. Decision criteria under uncertainty. Maximum expected utility is a decision criterion that chooses the alternative with the largest minimal expected utility. Reliability weighted expected utility is a decision criterion that takes into account the reliability of probability estimates. Ellsberg's index is a decision criterion that considers the degree of uncertainty. Levi's lexicographical test is a decision criterion that prioritizes the most important criteria. Gardenfuz's and Salem's modified MMEU is a decision criterion that takes into account the decision maker's preferences. The paradox of ideal evidence is illustrated using the example of weather prediction. Meteorologists predict a 50% chance of rain tomorrow, and historical data indicates a 50% accuracy in past rain predictions. The historical accuracy seemingly supports the initial 50% probability assignment. Subjective probability theory proposes reinforcing the expectation of a 50-50 chance based on this evidence. However, a critical perspective questions the necessity of additional observations when historical accuracy aligns with the predicted probability. Doubts emerge regarding the value of collecting more data if past performance closely matches the initial assessment, creating a paradox. The paradox of ideal evidence is illustrated using the example of 2 urns. Urn 1 has 50 red and 50 grey balls, while urn 2 has an unknown mix. Option A offers a 50% chance of winning a red ball from urn 1 and 50% chance from urn 2, while option B offers a 50% chance of winning a grey ball from urn 1 and 50% chance of winning red or grey from urn 2. People often prefer option A, even though the probability of winning a red ball is the same for both options. This illustrates the impact of uncertainty and the inclination to favor known probabilities, highlighting the complexity of decision making under uncertainty. Here are examples of binary and multi-valued measures of probability. For a binary measure, imagine you are trying to decide whether to invest in a new company. You believe there is a 50% chance the company will succeed and a 50% chance it will fail. For a multi-valued measure, imagine you are trying to decide whether to invest in a new company. You believe there is a 30% chance the company will succeed, a 50% chance it will break even, and a 20% chance it will fail. Example of decision criteria under uncertainty. 1. The maximum expected utility decision criterion. The example involves choosing between 2 job offers. Job A offers room 60,000 per year with a 50% chance of being laid off, while job B offers room 45,000 per year with a 0% chance of being laid off. The maximum expected utility decision criterion would advise selecting job B for the security it provides, even though it offers a lower salary. 2. Reliability weighted expected utility decision criterion. The example involves deciding whether to invest in a new venture. You have a reliable source offering 80% accurate information and an unreliable source providing 100% accurate information. The reliability weighted expected utility decision criterion would suggest relying on the 80% accurate but more reliable source for decision making. 3. Ellsberg's index. If you are contemplating an investment where you estimate a 50% chance of success but are uncertain about the probability of failure, Ellsberg's index decision criterion would recommend opting for the option with less uncertainty in the context of Ringgit Malaysia. 4. Gardenfuz's and Salem's modified MMEU. If you are choosing between 2 cars, car X is more expensive but has better fuel efficiency, while car Y is less expensive but less fuel efficient, the modified MMEU decision criterion would guide you to choose the car that aligns more closely with your preferences. 5. Levi's lexicographical test. If you are considering 2 job offers, job A pays room 60,000 per year with a 50% chance of being laid off, and job B pays room 45,000 per year with a 0% chance of being laid off, the Levi's lexicographical test decision criterion would recommend choosing job B for its job security, prioritizing stability over a higher salary. In conclusion, this chapter on decision making under uncertainty has explored the intricacies of decision making dynamics and the challenges of making choices in uncertain scenarios. The chapter has introduced measures of incompletely known probabilities and a range of decision criteria, each providing a unique perspective on decision making. By understanding and utilizing these tools, decision makers can make informed choices that take into account the uncertainties and risks involved. That's all from me.